All right, so we're looking at exponential models here. This isn't too hard. We got to make sure we identify what we're talking about. So we got bacteria in a petri dish, self-duplicating. They tell us that T is in minutes. They tell us BT is the number of bacteria. They give us an equation to find the number of bacteria, and they ask us when 20 minutes is. So we can assume T is equal to 120. It's pretty easy. So, I mean, this one is actually, they're asking us BT at the point at which 10 times 2 over T to the 12th power. But here's the thing. They tell us what T is. So we don't need to write T. We can actually write 120. And 120 divided by 12 is 10. So we got 10 times 2 to the 10th power. And that answer is going to give us the number of bacteria. It's going to give us BT, number of bacteria. Okay, so let's just type that into the calculator. I told you this stuff, I mean, it may look complicated. Just trying to get y'all ready for your SATs. And this bacteria started off with 10 bacteria. It was doubling. And now it's been 2 hours. And so we're going to see how much bacteria has been. And dang, it started off with 10. After 2 hours, it's at 10,240 bacteria. That's a lot of bacteria. Let's see if I got time for one more. All right, so on this one, let's see what they're talking about. Let's grab our pen. Okay. Takami plants trees in his backyards and studies the number of branches grows over time. He predicts that the relationship N and the number of branches, T, in the elapsed time in years since the tree was planted, can be modeled by the following equation. Okay. So he's got a little PERT equation there. According to Takami's model, how many years would the tree have 100 branches? So remember that they told us here is different than the last problem. They're asking us N is equal to 100. So they're asking us to find T. On the last one, they asked us to find the number of bacteria. Okay. They're telling us the number of branches. Okay. So they gave us time on last time. This time we're looking for time. Slightly different. So we set up the equation slightly different. We got 100 is equal to 5 times 10 to that power. Okay. We're going to divide both sides by 5, just that initial value. So we see that real growth. 100 divided by 5 is 20. Okay. So we got 10 to the 0.3 T power. What I like to do right here is I'll take the log of both sides. Log 20. What that's going to do is force this to come down. That exponent is coming down. And now you got log base 10 of 10, which is just 1. That means times 1. That's why it cancels. Then we're going to go ahead and divide that bad boy by 0.03. You see what I'm saying? We're going to divide it. We don't really like decimals in the denominator, so we're going to multiply top and bottom by 10. And that's going to make this move over one time. And so what we're going to end up with, and I'll write it over here, just so we got more space, 10 over, you got log base 20 times 10 all over 3. So they actually want us to have an exact answer. So we're going to write that. 10 times log 20, and all of that, we're going to put that over 3. And, that's how it goes. I mean, if you type that in the calculator, it would give you a particular time. You would say this many years. No one says 10 log 20 over 3 years. But this is what you're going to need for the SATs. Hopefully my videos have helped you with these style of questions, break down the word problems and everything like that.